Welcome to Crystal Clear Chemistry channel. In this video, we are going to discuss and explore in detail about the Aldol condensation. Especially the plus one, plus two students and the intermediate students would have heard about this Aldol condensation, right? Which is very important topic for mains and NEET. In this YouTube channel, I am going to upload important topics for the entrance exams like JEE mains and NEET. If you really like the video, please share the video and subscribe to my channel. Without any delay, let's get into the Aldol condensation. It is a fundamental process in organic chemistry and it is very important in order to synthesize the complex natural products like steroids and terpenes. And in order to synthesize some of the antibiotics and anti-inflammatory agents, this aldol condensation is a very useful reaction. Hence, let us see what it is and how can we expect the products from different types of reactants. Then, what is aldol condensation? It is a reaction between two molecules of either aldehyde or ketone or between aldehyde and ketone, resulting in the formation of a new carbon-carbon bond and readily forms a beta hydroxyaldehyde or a beta hydroxy ketone. Let us take an example now. Suppose if we consider acetaldehyde molecule CH3CHO acetaldehyde, and as it is the functional group, the carbon which is next to the functional group is called alpha carbon, and the alpha carbon, the hydrogens that are attached to the alpha carbon are nothing but alpha hydrogens. So those carbonyl compounds which are having at least one alpha hydrogen definitely undergo condensation reaction in presence of a strong base under low temperatures. For example, if we consider 2 moles of this acetaldehyde molecule in presence of a base like NaOH or KOH or calcium hydroxide or barium hydroxide, if we consider all these strong bases presence definitely makes the carbonyl compounds to undergo this aldol condensation. And here you will get the product as CH3CHOH, CH2CHO, which is nothing but beta hydroxybutyraldehyde, which is also called aldol. Why it is called aldol means this is the aldehyde group and this is alcohol group. So the compound, the same compound contains both aldehyde and alcohol. Hence you can say it's an aldol. In the first step of the reaction, CH3CHO, the OH minus ion from the base readily takes away this alpha hydrogen and converts into water where the CH2CHO minus carbon ion is produced. So carbon ion formation is the first step in the aldol condensation. And in the second step, what will happen? The second acetaldehyde molecule. See, suppose if we consider acetaldehyde molecule, the carbonyl group is present, we already know. And this is the polar bond, and here you will get that partially positive charge onto the carbon atom. On this carbon atom, this carbon ion will come and attack. So that you will get that alkoxide. See here, this bond shift onto the oxygen. That means you will get a O minus here. And on this carbon there is a hydrogen. I have written the hydrogen. And whatever the carbon ion group is there that attacks on this carbon, so that I am writing CH2CHO here. This is called alkoxide ion. So in the first step, deprotonation uh, by the OH minus ion from the strong base. And in the second step, there is an attack of nucleophile on this positively charged carbonyl carbon so that alkoxide ion is produced. And whatever the water is produced in the first step will help the alkoxide ion to get protonated so that the alkoxide ion O minus ion readily takes away the H plus ion from the water and you will get the product like this. See CH3CO minus and CH2CHO plus H2O readily gives CH3CHOH CH2CHO plus OH minus, right? So this is called, see, this is again aldehyde group. This is alpha carbon and this is beta carbon. This is called beta hydroxy 1, 2, 3, 4. There are 4 carbon atoms, hence it is called butyraldehyde, which is a common name. 3-hydroxybutanol is the IUPAC name. Anyhow, this is the mechanism of the reaction. If I consider acetaldehyde, again one molecule of acetaldehyde, but let's take another aldehyde like propanol. Propanaldehyde I am going to take now 3 moles, 3 carbons aldehyde. Propanol I am going to consider. And let us see what will happen if acetaldehyde and propanaldehyde undergo condensation, the aldol condensation in presence of a strong base. Now listen carefully. If we consider acetaldehyde, no doubt we know it is having the alpha hydrogen. These are the alpha hydrogens. And where are the alpha hydrogens in the case of propanol? This is functional group and this is the alpha carbon and these are nothing but the alpha hydrogens, right? It has the capacity to convert into carbon ion. Let us consider the carbon ion that is produced from acetaldehyde. This is the carbon ion. And another carbon ion from the propanol is nothing but CH3, CH minus. See, suppose if H plus is removed from this alpha hydrogen, alpha carbon, then you will get a carbon ion like this, right? Now listen carefully. Let us suppose that acetaldehyde is a compound A and propanaldehyde is compound B. If only acetaldehyde is taken, 2 moles of acetaldehyde undergo condensation and we know beta hydroxybutyraldehyde is the product. But instead of taking only A, if I take B, then there is a chance of the combination of A and B, right? In that case, let us see how many products you will get here. What are the carbon ion formed from the compound A? Let's consider it as a C. And the carbon ion formed from the B is nothing but D here. Now, suppose if again another acetaldehyde molecule A readily combines with the carbon ion C, you will get one type of product. And instead of C, if it combines with D, again acetaldehyde readily forms another aldol product here. Similarly, B combines with C and B combines with D readily forms 2 more products, right? First product A plus C. What will happen if C attacks on the CH3CHO? CH3CHO means this carbonyl compound, this carbonyl group. The pi bond readily shift onto the oxygen so that the CH2CHO minus attacks here and hence you will get a CH3CO minus H, CH2, CHO. On protonation, the alkoxide ion readily produces CH3CHOH, CH2, CHO, right? Now, let us see what will happen when A reacts with the carbon ion B, because we have considered the mixture of A and B, right? That's the reason why if one of the molecule of B produces the carbon ion D, it has the chance to attack even onto the A. That's the reason I'm writing A plus D here. So CH3, C double bond OH, again the acetaldehyde A. Now this time the D carbon ion, the minus ion, readily attacks on this carbon, and you will get a CH3CO minus, and here CH3. Look at that D. By looking at the D only, I am writing here all this group, the total group here, and whatever the H is there, the H remains here, right? So we are going to get an alkoxide. No doubt it readily produces again the alcohol beta hydroxy compound. So CH3CHOH, and then the CH readily combines with, I mean, which is attached to this CH3CHO. This is the second product. I'm going to write B plus C now. B plus C readily gives CH3CH2, C double bond OH. This is propanaldehyde. If this pi bond shift onto this oxygen, this minus ion attacks on the carbon, so that you will get CH3CH2, CO minus, and then here CH2CHO, and here you will get that H. And this oxide is protonated, you will get the hydrogen here. This is the third product. And similarly, when B and D reacts, see here this is the propanaldehyde, and this is the carbon ion that is obtained from the another propanaldehyde molecule, and you will get, let us see what type of product you will get here. Here I'm going to consider CH3CH2, C double bond O. Again, if this minus ion attacks onto this carbon atom, you will get a CH3CH2, CO minus H, and then this whole group we need to write here, nothing but CH, CH3, CHO, right? As alkoxide gets protonated, I'm going to write again the H here. That means CH3, CH2, CHOH, CH3, CH3, CHO is the fourth product. So there are of total four products from two different carbonyl compounds. Instead of taking the aldehyde having, now let us see the second example. I am going to consider this time HCHO, formaldehyde, and acetaldehyde. Now listen carefully. This aldehyde has alpha hydrogens. If we consider this aldehyde group, there is no alpha carbon only, no alpha carbon. That means no alpha hydrogens. But this acetaldehyde is having alpha hydrogen. So there is a chance of production of carbon ion from this acetaldehyde, which is nothing but CH2CHO minus, and this nucleophile readily attacks on the carbonyl group of formaldehyde, so that let us see what type of product we can expect here. This O minus See, suppose if this double bond is shifted onto the oxygen, the positive charged carbon atom will be attacked by the nucleophile CH2 CHO minus, so that you will get a CH2, the CH2 O minus, and then CH2 CHO, right? Here, in the case of acetaldehyde, the one of the hydrogen is replaced by this CH2OH. On extensive aldol condensation with two more formaldehyde molecules, you will see all the alpha hydrogens gets replaced by the CH2OH, so that the product will be CH2 of OH three times, and then CHO will be the final product. Then formaldehyde and acetaldehyde undergo crossed aldol condensation. Similarly, when benzaldehyde and acetaldehyde undergo aldol condensation, you can see the product here. Let's consider the last example, a special type of aldol condensation which is called a intramolecular aldol condensation. So here the OH minus ion readily take away the H plus from the CH3, so that you will get a CH3 C double bond O, CH2 of 2 times here, C double bond O, CH2 minus. Carbon ion will be formed. So whatever the carbon ion is formed, that readily attacks on the carbonyl group of the same compound, so that cyclic compound will be formed. And in this cyclic compound, let us count how many carbon atoms will be there. So 1, 2, 3, 4, 5. So 5-membered cyclic compound will be produced. I am going to write CH3, the same CH3 here, and this let it be the same C where the alkoxide ion is produced, and the remaining CH2s I am going to write here CH2, CH2, and then the C double bond group. Then whatever the CH2 is there, it readily attacks on this carbon atom. A new CC bond is formed between these two carbon atoms, right? This you can represent like this. See here, I am going to show the 5-membered ring here. Let it be the C double bond O, and here you will get a CH3 here, right? And O minus also on the same carbon atom, and the remaining two CH2s are like this. In the case of this 2,7 diketones, different type of product you can expect here, because the carbon ion is formed this time from the inner alpha carbon. This is in the last example we have taken the alpha carbon, which is the outer alpha carbon, but whenever there are 2,7 and 2,8 diketones are there, the alpha hydrogen which is inside the two ketones, this alpha hydrogen will be eliminated in the first step itself. That's why again we are going to get a 5-membered ring here. So please note this point, okay? This is all about the aldol condensation. Whenever aldehyde and ketone group is present in the same compound during the intramolecular aldol condensation, again the carbon ion will be formed which is adjacent to the aldehyde group. Okay, that is also the point to be noted in this aldol condensation. That's all for today. Thanks for watching the video.